Hey guys, how are you doing? This is a very simple beginner-friendly project. We'll be building an HRMS, which is a human resource management system, and we'll be using Golang, GoFiber, and MongoDB. So essentially, you'll be learning how to use GoFiber along with MongoDB, but in a format of a small project. So it's a very good way for a beginner to get their feet wet and actual applying what they've learned till now. And since it's beginner friendly, there won't be any concepts which throw beginners off, which are confusing to beginners, like interfaces. There won't be any interfaces. There won't be any Go routines or channels, worker pools. There won't be any pointers. The structs also won't be complex, as in we won't have different relations between structs and modeling. All of that won't be there. And so this year, I'll create a lot of videos for beginners because in all my previous videos, they're more for advanced developers and intermediate developers. So in case you're an intermediate or advanced developer, you can go and check out all the other projects that I have in the playlists. You will find something really interesting. Now, since this video is very beginner friendly, I won't even be having different files. I'll be having everything in the same file, Mongodb file. So we won't be learning about project structure here because it's again for complete beginners. But in case you want to see more complex project structures and design patterns and all that, I have a lot of projects already on my playlists. Yesterday we built a product or a project with a CRM with GoFiber, but we used SQLite in that. This is why today's project is slightly different because we're using MongoDB. So if you're a beginner, building both of these projects for you is going to be very helpful because you've learned how to do it with SQLite. Today we're doing it with MongoDB. Maybe tomorrow I'll build something with Postgres, and then after that with MySQL, then with Redis. I've not planned it yet, but that could be how I, build some examples. So at least these two are there. So just do these two at least for now. Today, the project we're doing today, which is with MongoDB, and the one with SQLite. So you'll get quite comfortable with using Golang, at least in the beginning, right? On how to build like very basic, simple APIs and projects. So without further delay, let's get started. And I'll just open up my terminal now. As you can see, I've opened up my terminal now. I'm using PowerShell on Windows for this project. And it doesn't matter how you've set up your Go path or how you've installed Go. We'll be using Go mod, and that means that we can have the project anywhere, and Go mod will handle the dependencies for us. So I'll create a new directory for myself for this new project. I'll call it Go Fiber Mongo HRMS. And I'll cd into it. And I'll open up, so before I open up this on a VS Code or any other code editor, I'll go ahead and say go mod init, which initializes your mod file. And you'll give it an absolute path. You'll say github.com/akil/ and the name of the project, Go Fiber Mongo HRMS. Okay, and now you can go ahead and open it up in a code window. I'm using VS Code. VS Code works out really well for Golang. So in case you're using something else, just try VS Code once. So as you can see, there's already a file called go.mod that exists for me, right? And it mentions my name of the project and also mentions the version of Golang that I'm using, so that if anybody else takes up this project, they can easily install all the external packages that I'll use using this file. And all the external packages that we'll install in our project, for example, the drivers that we'll use to work with MongoDB, you'll see them listed out here. So as I said, we'll have only one file in this project. And so main.go is the most important file usually in a Golang project. And what you want to start off with is you want to say package main. And you'll want to import some things here, okay? And after importing those things that we'll talk about in a while, mostly around the things that we'll import will be mostly packages around MongoDB. We also want to create a Mongo instance of a session with MongoDB so that we're able to interact with MongoDB. And it will be basically a struct. So Mongo instance, struct and you'll have a client and you'll have a database. So a struct is basically your own data type. So you get some data types with Golang, like int, string, uint, all of those, float, and all of those different data types. But what if you wanted to create your own data type, right? You can do that in Golang using something called a struct, almost like an object with JavaScript. And so it'll have two different things. One is client, one is DB. And here we'll have to write some things, which I won't write as of now because we have not installed those packages. But to be able to work with this struct, I'll need a variable called Mongo instance. Now this is how you define variables in MongoDB, in Golang. You have this variable mg, and it's of type, this is the data type. So it could have been string, it could have been int, but right now for this, for what we're doing right now, it's Mongo instance. Mongo instance is our own data type that we've just created, right? It's a struct. It has a client, it has a database. Okay. So I also want to define two constants. So the first constant will be the DB name of the database that I want to work with. DB name, and it's going to be called, let's say we call it Fiber HRMS, and don't define a constant for Mongo URL. Now in this video, I'm going to be using the local host MongoDB. That means that MongoDB is installed in my local computer and it'll be running on a port, and MongoDB usually uses 27017 as the native port. Now you could be using MongoDB on your local machine like I am using to keep things simple. But if you are using a fully managed service like MLab, they will give you a link to embed in your program. And that's the link that you'll put here in the MongoDB URI. Okay, so in my case, I'm using localhost. So this is how I'll write the link. So it'll be MongoDB. And after these two slashes, you'll put your own actual link that you got from your managed service. In my case, it's just localhost. And my port is 27017. The way you have configured up your MongoDB also makes a difference here, because you might have to write your username @ your password and then the localhost. So in my case, the way I have configured my MongoDB, I have not kept any username or password for my admin user to, as in it can connect directly with MongoDB without requiring any username or password. In case you don't know how to set it up like that, there is a video on how to install MongoDB. I think it's long. I put it up long back. So you'll just have to search a bit on my channel and you'll find it. It's very simple. It's very straightforward, right? You just set up MongoDB without any users or passwords. It's just easier to work like that, especially if you're building very simple projects, right? And here you want to add the DB name. The DB name is Fiber HRMS, and that's what will be added. So when your MongoDB gets connected, it'll get connected to 27017 and by default to this database called Fiber HRMS. Now comes an important part, which is basically how you define your employee. Now in human resource management system means it's a company and they have a database of their employees that work there. So the employee will be a struct. Now you can manage name as a string, or salary as a string or as a number. But how do you manage all of that together for one employee, right? So that's why you create a struct, right? So there are these data types that Golang understands. Then there are these data types that you can create called structs that you can make Golang understand, because they have these different fields. Like for example, there'll be a field called ID, field called ID, field called name, just name, and field called salary, field called age. And all of these fields will have a data type like string, for example. Name will be string, salary, it's float, and age is also float. Right, so now these fields like ID, name, salary, age, they're of data types string or int or float, whatever. So that means Golang can understand what we're trying to say, right? But all of those combined make up a struct. And since Golang understands those individual things like ID, name, salary, age, it will also understand this whole struct, right? Which is now a new data type that we've created for our use. Okay. Now, there'll also be something else that I'll add here, but not right now. And I'll explain to you what it is. But just keep this like this. Keep this as just a struct for now. Okay. Now you'll have a function for connection, which basically helps you to connect your Golang to MongoDB. So you'll have the connect function here. And every function basically takes in something and returns something. So error is what's returned by this function if things go wrong, and it takes in nothing basically. So there are these empty brackets, right? And inside this will be a function definition that we'll write in a while. And at the end will be funcMain. So funcMain is an important function usually in the main file. funcMain is the most important function, and that's where the control of the program usually begins. Okay, and here you want to first define your app. Now, if you've used Node.js by any chance, and if you used Express, because you have to use Express with Node.js, right, mostly. So if you've used Express, that then you know that you have to define the app variable in the beginning, which is basically an instance of Express, and that's how you interact with Express. And exactly that's what we're doing here, because Fiber is the equivalent of Express. So Express is with Node.js and Fiber is with Golang. It's an exact equivalent, but Fiber is like, I think they say it's 10x faster or something like that. It's really fast, basically. That's all I need to know. Okay. So now when I say fiber.new, that means I should have had the Fiber package. So this is how you install in the import statement. This is how you import an external package. So you say go fiber /fiber/ v2. Sorry, it's a small v, okay? So it's a small v2. And you also want to get some MongoDB related packages. But for now, let's just keep it this much. And what we'll do is we'll go over to our terminal. And whenever you import a new package, right, you have to say go mod tidy, so that Golang will go online and find the model package for you, and it'll install it in your program. Now, after your Fiber definition, you want to have the standard functions, so which are also your routes, right? So the first route that you want to define is /employee, and this is the get route. Then the first route with the get method is going to help you get the list of all the employees that are there in your database. Then you want to have a post route, and then you want to have a put route and a delete route. Okay. And for post route, the route will be the same. For put, there will be just an ID after employee. For delete also, there will be an ID. And the way you start off a function is basically when something lands on this route, or somebody calls this route, you want a function to get called. And that function basically can return an error if something goes wrong. And it'll have a definition, right? The function will have a definition. The function usually takes C, which gives you fiber.context. C, which basically is type of Fiber, which you get access to from here, from the library Fiber.context. Now, there's something really important here for you to understand, is that whenever you have a function like this, like a route function, you want the request, you want to be working with request, and you want to have the ability to send out a response, a JSON response. By request, you mean whatever the user sends, let's say from his Postman or from curl, whatever the user sends to the program. And it could be an ID, it could be like in case of the post request where you want to add a new employee, it will be the new employee data, right? The data for the new employee. So that will all come in the request. So you need the ability to work with that request, and you want to be able to process that. So like let's say you added a new employee, or you deleted an employee using the ID, or you updated an employee using the ID. And you need the ability to also send out a response back to Postman or to the terminal. So both of this can be done using fiber.context. And C is how you're going to be accessing the response and request. Okay. So this is what was important for you to understand. Now, before you start with all this, right, you also need to be able to connect with a database. So you'll call the connect function here. And connect function is exactly the same function which you're going to define out here. So what's happening here is you'll have if error, you'll handle the error here itself, and error not equal to nil, then you'll log.fatal error. So the log library helps you to log out errors, and we have not imported it here, so we have to import the log library here, right here like this. All right. And what we want to do now is we want to start creating our connect function. So come over to your connect function, and we'll say mongo.new client. Basically, you want to create a new client for MongoDB. Now, this word Mongo basically comes from the Mongo library that we have not installed or imported yet. So let's go ahead and get the MongoDB libraries. The first one is go.mongodb.org/mongo driver/pson. So firstly, just get Mongo actually, just get Mongo, right? And the spelling here is wrong. So just make sure you write the right spelling, which is Mongo is M-O-N-G-O and driver. Okay, so that's the main important library. Now this library has a few more things that you can get, right? So the first thing that you can get are the options. So you'll say go.mongodb.org/mongo driver/mongo, and then you'll get some options. And then Mongo has some bson and primitive that helps you to create that ID, right? So we'll have to import that as well. So you'll say go.mongodb.org/mongo driver/bson. This will help us to create the ID for every single record. It will be a bson ID, and we'll have again mongodb.org/mongo driver/bson/primitive. Now, if in case you're worrying that you'll have to remember these 4 links, you don't have to. You just use it once here, and every time you now connect with MongoDB, you just have to copy those 4 links. I didn't copy them. I could have copied them, and any other tutorials you'll see online, they will copy them. But I'm just showing it to you, so that you understand that you go to go.mongodb.org website. Then you go to the MongoDB, which is the main Mongo driver, which is like the main parent library. Then you have like Mongo, which is the package, the ORM that you use, and then you have your options. Then you also have your bson and primitive. Okay, so that's why I just wrote it for you to see that they're all linked and all related, so that you're not just blindly copying all of that. Okay, but mostly from now on, once you've done this project, you just have to copy and paste these 4 lines everywhere. So what happened is when I just pressed Control S to save it, there are some plugins or extensions that I'm using for Golang that basically recognize that I'm not using those packages right now. So they have removed those packages for me. So I'll Control Z and not save it as of now. If I try and save it, it'll remove those packages that I'm not using. So it basically helps with error solving. And you can also go to your, your extensions. And you can just write Golang, and the first 3-4 packages that come, you can just install them. They just make development a little easier. Now that we have installed or imported these packages, now it's going to be very easy for us to work with our connect function. Okay. So you say mongo.new client, and then you say options.client dot apply URI. So this function, right, the options.client dot apply URI, you already get from the Mongo package that we're using. And apply URI is a function where in that function you pass basically your Mongo URI that you've just created. So all it's doing is it's going to apply that URI and basically going to connect and create a new client for you for that URI that you've just created or just given to this program. And you'll get access to this whole thing as in the complete connection instance using the client, right? So whenever you want to work with client, you don't want to keep writing this all the time, right? You want to be able to, you want to get all of that in one variable that you can use later on. So that's what the client is in this case. And in case you don't know what this is the walrus character. This basically, defines a variable and also declares and defines at the same time. So here you also want to have something called as a timeout. Now there are some functions with MongoDB that are blocking functions like insert, right? And you don't want it to block the entire program. So you want to always have a timeout. And timeout basically with this MongoDB package for specifically, it uses the context package that already Mongo has to give you this ability to define timeouts. So this is how we define timeout. So you'll say context dot with timeout. So in case your MongoDB is not responding or something goes wrong or the insert is taking too long, you have a timeout. You don't want to block the entire program. And now this is not compulsory, but this is a good practice. I mean, you have to. It's not like without writing this, the program won't work. It will work without it, completely fine. But I recommend always writing this down. Okay. So you'll say backgrounds, comma, and you can give any time here. You can give a time of 10 or 20 or 30. Now, what you'll notice here is that time, as soon as you write time, it's not recognized by Golang. That's because Golang is so modular that Golang doesn't even have the ability to print things, or even the time package even the time ability to understand time is also not inherently available inside Golang. So this basically makes Golang very lightweight and very fast. Okay, that means that time is not understood by Golang. So that means it's a different package altogether. So you'll have to come up here and you'll have to install the time package on your own. Now, the extensions that I'm using were able to get the context package for me automatically. So when I used context out here, even context is not understood by Golang, but somehow the extension decided to get the context package for me automatically. I didn't have to do it. Anyhow, there's a squiggly line here that means context. There's no function called with timeout, and that's because the O should have been small. And now Golang starts understanding it very quickly. You get a squiggly line here with client and error. That's because you've defined these and you have not used these as of now. And Golang has a problem with that. So in case you define something and you don't use it, Golang has a big problem. So we'll quickly, we'll use it. We'll basically use these two variables. Okay. Now, you want to run this cancel script at the end of this program. And that's why you use defer. And now you want to say client.connect, and you want to pass this context here. So here, I forgot to show you that CTX and cancel are the two things that you'll get here, right? So when you say Control C, whenever you run your program, right, in the terminal, you say Control C, it'll basically cancel this. It'll have that timeout here. Directly, it'll just cancel the entire operation, whatever is running out there. So now you have client.context CTX. The context is what you will pass here to be able to connect to the database with the right context. And you will again get that in the error. If there's an error there, you'll get that in this error variable that you'll handle now. And you'll also have a variable called DB. So we'll say client.database, and you'll pass the DB name here. So you've connected to the database, to the MongoDB, but you also want to connect to the right database, right? And this is how you do it. And you'll be able to use this now, the database using this DB variable. So this error that we've received, that we may have received if things went wrong while connecting or while creating this new client, those errors we'll handle right now. So we'll say if error not equal to nil. And by the way, this is a common theme with Golang, that always when you write something and then you might expect an error there, you'll always handle that error just there itself. So here I will handle the error and we'll have return errors. Now you might remember that we had created our MG here, right? Our instance MG. And here we'll say MG is equal to Mongo instance. Then you'll have client, comma, DB. And you'll return nil from this function. Okay. So you've created your MG, which is your Mongo instance, which is of type struct. And the values here for the client and database, right, have now been set. So this is what we did here. In case you didn't understand, is that for the client, it comprises of two things. Remember, struct is basically your own data type. And in this case, it's Mongo instance, which is a struct. And it has two things. One is the client, the other is the database. So client means the client, MongoDB, and database means the database name that you want to connect with. And that's why we created this DB, and that's why we created the client, these two variables here, so that we're able to define our own struct, complete struct. And MG is basically what we'll be using to further on if we want to work with the database. So that's what your instance consists of. Now here, you want to say that client is of type mongo.client and DB is of type mongo.database. Make sense? Right? Now, I know I said I won't use pointers, and this star is basically a pointer. So what we're saying is that it's a reference to mongo.client and mongo.database. If you don't understand pointers right now, it's not a problem. You don't have to really worry about it. I'll have really basic videos coming up on what pointers are and how they work and why they're used. For now here, this is the only place where we're using it. So, and also the other place where we're passing a pointer to the fiber.context. So just have to remember that you have to put stars in front of these for now. And we're just passing these by reference. About pointers, I'll create like a 20-30 minute video just explaining pointers. So don't worry about this right now, okay? And there's no advanced pointers getting used here. It's just for this part, so don't worry. Anyhow, now coming to your employee struct. Now there's something that I want to do here. And I think right now is the right time to do that before we start creating all these handler functions for our routes. So one important thing that I want you to understand is that Golang does not understand JSON natively on its own. Just like if you're coming from a JavaScript background, you might feel that JSON is basically understood by all languages, and JavaScript people have this confusion because they feel that JavaScript understands Golang JSON, so that means all languages will understand JSON. But it's not like that. It's because JSON is JavaScript object notation, so only JavaScript understands it natively. All other languages have to use some packages to be able to understand it. In our case, we have to use a package called JSON. We have to do a lot of encoding, encoding and marshalling basically for understanding and working with JSON. And but in this case, since we're using Fiber takes care of a lot of things for us automatically by default, and it's all happening under the surface. Like a lot of marshalling is happening under the surface. So Fiber makes things very easy for us. But otherwise, by default, Golang does not understand JSON, right? So that's why whenever you define a struct, and the struct is going to actually represent the data in the database in your MongoDB, which understands JSON, by the way. It's a JavaScript database. And the data that you're going to get from the user as a request is also going to be JSON, right? So when data comes from the user as a request to Golang, it does not understand it because it's JSON. And when data comes from the other way, from the MongoDB to Golang, and then Golang has to send it to the user, again, Golang does not understand it because it's coming as JSON. So this is why you have to tell Golang that, hey, you understand ID as string, and this is what it's going to look like to you, right? ID is going to be string and name is going to be string. But in JSON, it's going to look a little different. So we just have to help Golang here. And we have to say in JSON, it's going to look like this, man. ID, and we'll also write omit empty for ID. And as you may have worked with Golang, with the MongoDB, it also needs bson for the ID. And this is how it represents ID at the database level. ID, comma, omit. Now, I'll show you name also, and then I'll explain the difference here. Okay. So what's happening here is name is understood by Postman, is understood by your terminal when you or by the user when you send a curl request, right? Name is understood as in JSON as name with small n, whereas Golang understands it as name with capital N, and for Golang it's a string, right? But when it comes to ID, the Postman understands it as JSON ID, whereas MongoDB stores it as bson, which is underscore ID. So this is why we have written bson again, right? For MongoDB. I hope that's understood. And then you have your salary, which is again JSON, and your age, which is age in JSON, right? So all of these fields, they have small n, small s, small a, whereas for Golang to understand and Golang to work with this information, it'll be capital N, capital S, capital A. So now we want to start working with our main functions, the main handler functions like get and post, put, delete, all of these functions, right? The route handlers. So we'll start with get. That means we want to get all the employees from our database. To do that, you need, like I told you, Golang does not understand JSON, right? And you'll get something from the database. Golang needs to understand it, and Golang needs to send a JSON response to the front end or to Postman. Now, to be able to work with that, I need a variable called employees, and it's of type employee, right? So this is how you define a variable. You say this is the variable name, this is the type, and you see these two brackets here. That means it's a slice. So it's okay if you don't know what slice is. Slice is basically like an array, but instead of containing just numbers, it contains actual objects. By objects, you mean basically all of the things, the multiple things that this array will contain will be an actual employee, the whole employee, right? So this means that if you're coming from a JavaScript background, this would mean that it's an array of multiple objects. So now you'll initialize it using the make command and employee pseudo. So you've defined your employee variable, right? This will help you to work with the records that are fetched by the database, from the database. Now, to get something from the database, you have to use the find command that MongoDB already has, right? So the find command, you usually send a query. In our case, since we want all the employees from the database, that means the query that we have to send is completely empty or just two empty brackets. Okay, so we'll have to define the query here. So query is equal to bson.t. And inside these two curly braces, you'll define the query usually. In our case, the query, like I said, are just two empty brackets because it's an empty query. So this is the query basically. So we've defined the query. Now, you want to use the find function that MongoDB will give you. And inside that find, you'll pass query, right? The query that you've defined here. But you'll also pass the context. Right? So you'll pass c.context and you'll pass query here. So I hope that's making sense. Now, this find function is available to you inside MongoDB. You know that already. And how are we talking to MongoDB in our program? We're talking to it using the MongoDB instance that we've defined here, right? The Mongo instance. And the Mongo instance has something called as DB. So we want to target that Mongo instance, and we want to talk to the database, exact database. Inside that, we want to talk to a collection. Collection is like a table. So with MongoDB, you have collections, and with an SQL database like Postgres or MySQL, you will have tables. So if you're familiar with tables, it's the same thing. It's just a collection. So you want to go to that instance, you want to go to the database, and you want to go to the collection, and then you want to basically run the find command. That means you'll go to the instance mg dot, you will get the database inside mg, right? So it's mg, and this database you've already defined the variable there already. It's already set. And dot, you want to get the collection. So the collection, sorry, it's C capital, and everything else is small. Collection is employees, and you'll say dot find, and you'll find the query. And here, what you get back is usually the cursor. Basically, it'll have all the employees records, or you'll get back the error. So now you want to handle the error. So you'll say if error not equal to nil, and for the error you want to return a status of 500, which is basically your internal server error. You want to send a string, which is your error string. Basically, you're sending the entire error itself. You've defined your employees already here. Okay, one small mistake that I see here that I've made is that this bracket is not here. It's actually here, the close bracket, because it's a slice, right? Employees a slice. This is how you define a slice. Those two brackets and then employee. All right. Now, what you'll do is you'll use this cursor. And here also I see one small mistake is that D is going to be capital, B will be small, and now Golang will understand it. So that's why the squiggly line quickly goes away. All right. So now what you want to do is you want to say cursor dot all C dot context, comma, ampersand employees. When I say ampersand employees, I'm basically passing a reference to this variable employees that I've sent. And what's happening here really is basically whatever data we've received in our cursor, right? And from this function that you've run here, cursor, which is all the data of all the employees from the backend that has been received. This is going to basically convert that into a format, into the structs that are understandable by Golang. So that's why you pass these employees, right? So in the end, you'll get employees, right? But that will be basically a slice of multiple different employees. And we did this because Golang cannot understand JSON, which MongoDB understands. And when MongoDB sends it some data from by running that find function, you now need to convert it into something that Golang understands, right? And this is how you've done it. So you'll say if error is equal to, sorry, in front of this you want to say if error is equal to, and error is not equal to nil, and you want to return c dot status 500 dot send string error dot error, right? And here you want to return, if everything goes well, you want to return the employees that you just now converted. Employees was that variable that you defined, which was a slice of employee, right? That means multiple employees will be there. And that basically is what you got from the database. You converted into a nice, understandable format. And in JSON, you sent it in JSON to as a response to the front end. Okay, so I hope all of that makes sense. Now we'll move towards our post function. So we'll make some space here. For post function, we'll have our func. And similarly, this function will also accept a pointer to fiber.ctx, which gives us access to our response and request. This is how we're able to use response and request. And it also does a little bit of marshalling and marshalling for us. Like here we did c.json, so it can do some marshalling and marshalling for you by default. It does take a lot of work away from you and gives you some abstraction. So here you want to define your collection. So we'll say collection is mongodb.database.collection and employees. So instead of saying this again and again, mgb.db.collection.employees, I've defined it and I can now use it in a variable called collection. And I'll create an employee. Now, when creating something in a database, right, you have to use the insert function that MongoDB will give you. And also you'll get just one employee. That one employee data that you're getting from the Postman, that as in the user will send the data of a new employee. And that new employee, right, variable is going to basically go to the database. And this is how we'll define that employee variable is equal to new employee. So when we say this, right, you can define it like this, or you can say var employee and employee. You can say like that, or you can say employee is equal to new employee. All that's doing is that it's defining a variable called employee, which is of type employee, the employee struct that you've already defined, which has ID, name, salary, and age. Right? So now you have defined your employee as well. And what you'll do now is you'll get some data in the request. You'll get the data of an actual employee, as in the user wants to add a new employee, right? So he'll send a new employee data like name and all those different things, name and salary and age to this API. And this API needs to now read that information. And it does that using C, which is basically your Fiber context, dot body parser. So you'll say body parser. And when you say employee here, that means all that data basically becomes formatted in the format that you need, and you get it into this variable called employee, right? So it basically parses the body, which is in JSON. You're sending from JSON from Postman into this Golang program, into struct that Golang now understands. And after you've done that, you want to handle the error. So you'll say error is equal to c dot body parser employee, and if error is not equal to nil, there can't be any space between exclamation mark and is equal to. And here you'll return c dot status 400 dot send string error dot error. Okay. Now we always want MongoDB to create its own IDs. And this is why what we'll do in the beginning is we'll say employee.id is equal to 0. This forces MongoDB to create its own ID. And now I want to take this collection that I've defined here. So it's good that I defined it as a variable, because I can now keep using it. I don't have to always write this again and again. So I'll say collection.insert1. Now insert1 is a function that I get with MongoDB. So if you're familiar with MongoDB and the functions that you get with MongoDB, it's really easy to understand. You get insert1. Insert1 basically takes data and inserts that into your database, just one data. Into that insert1 function, you will pass c.context, comma, employee. So you received some data in the body. You used body parser to convert that into employee, which is your employee struct, and that employee struct basically is what you're sending to the insert1 function along with the context. And whatever I get back from this function after inserting, right, I'll keep that in a variable called insertion result. And also an error. So if the error is there, then I'll handle the error. If error is not equal to nil, that is, it returns c dot status 500 dot send string error dot error. The spelling of return is wrong. Now after it gets inserted, it'll come in this variable called insertion result, or you'll get an error. And this error, we'll handle it right now itself. And we want to do something with this insertion result. What we want to do is we want to get the ID from this insertion result that you get. right? Then this ID, we'll use that to search the actual record that has just been inserted in the database. And then after finding that record, we want to return that to the front end. Okay, and this makes us doubly sure that whatever we did the post request for right now, it was inserted into the database, and we can make that sure by actually going and searching for that record using the ID and then sending that record. And this makes it very sure that this data was actually inserted in the database. Make sure, yeah, makes sense. All right, so here first I'll handle the error, okay, quickly. So if error is not equal to nil, I'll give some space here. Then you want to do something. You want to return c dot status 500 dot send string and error dot error. All right. Now, like I said, we want to take the insertion result, which is insertion result, and we want to get we want its ID, right? So we want the inserted ID. And using this ID, we'll create a query, and then we'll find the record that has this ID to check if what we just inserted right now using insert one was actually inserted in the database or not. Okay. And so let's say value is equal to insertion result dot inserted ID. And basically we're building up a query, right? So the key is ID, and for that key, which is ID, the value is this inserted ID that you just received. And close it with inside another pair of curly brackets. And say filter is equal to JSON.d. Just like you had created a query here for get, which was bson.d, and the query was empty, right? Now you have bson.d. It's called filter, not filler, filter. And bson.d, then the query has key, which is ID, and the value of ID is basically insertion result that you just received right now, and the inserted ID of that. And you want to get the created record that we just created. How do you get it? You use collection dot find one, and you pass c dot context to it, and you pass this filter query that you just created. You pass it there, and that's how you get the created record. So I'll repeat again. You inserted the employee data that we just sent using Postman, the complete employee data, and you used insert one query to insert that data of employee. And you got that, whatever you got back from this function was stored in insertion result. And that insertion result also has a variable called inserted ID, which basically has the ID of the data that just got inserted. And you keep that, to build a query, and you keep that in this variable called filter. And this filter is basically what you send to find one function. And we're just rechecking that this data was created. And then you get that into this variable called created record. So this is the record that was just created right now by you. And this is what you want to send to the front end. So you will create a variable called created employee. Now you want to structure and format that data, right? So you say that created employee is a variable of type employee, which is your own struct, right? So created employee will have ID, name, salary, age, type employee. And you want to say created record dot decode, and you want to decode the created employee. Okay, we are doing this decoding because, as you know, Golang does not understand JSON. So we have decoded that into a created employee, right? The whole JSON that we just received from MongoDB. And now you want to send that JSON as response to the front end. So you'll say return c dot status 201 .json. By the way, 200, 201, 203, 400, 500, these are standard statuses, HTTP statuses. You can read more about them in case you don't know which status is used when. So you'll send the created employee. Make sense? Now, I've actually used insertion result here. So let me make sure if this is the same spelling I've used here. Yes, the same spelling. Now, a lot of these packages have these squiggly lines. So what I need to do, obviously, is I need to say go mod tidy, so it gets all those MongoDB and MongoDriver options, since I've not done that for quite some time now. And if I go ahead and save it, it removes one package. I don't know which package did it remove. Anyhow, let it be actually. So yeah, just save it actually for now. And you can see that all the issues have gone away, right? We don't have any issues now. Now we want to work on our put function, but let me first check if everything looks fine with the post function and if there's no big thing that we're missing as of now. Yeah, everything seems to be all right. So now we want to work on our put function. Put is basically your update. And then you have, at the end, you have delete. So I'll just create some space here just for some, clarity. And here, as soon as somebody hits this route, you want to call a function. You want to call a function, and this function is going to take C, which is of type fiber.cdx, returns an error. Yeah. Now the thing with IDs is that you get them very easily. You can access them really easily using the C, which is the context, C dot params. So the params will have the parameter, which is ID that you've just passed. And I'll capture this in a variable called ID param. And also, I will create it from hex. So I'll say primitive, the primitive package that we're using, say object ID from hex ID param, and I'll store that in employee ID variable, or we'll get an error. So either it'll get converted or we'll get an error. So it's giving a squiggly line for primitive. That means, so that means when I saved it last time, it had removed the primitive package here. So I'll copy this, paste it here, and I'll say slash primitive. All right. It's showing me 3 issues in the file. I know there are 2 issues from here because these 2 we have defined, but we have not yet used. Anyhow, so now we'll go forward. We'll handle this error that we might receive here. So if error is not equal to nil, we want to return c dot send status 400. Okay. And just like you did with post, right? So update APIs are usually very similar to the post APIs. So just like you defined a variable called employee and it was of type struct, which is employee struct. Similarly, we'll have it here, right? And similarly, the data you need to get from the body parser and you want to get it into this variable called employee. So very similar. So you will define a variable called employee is of type employee, and you can define a variable like I said, var employee, or you can just say employee is equal to new employee. 2 ways to define a variable in Golang. Many more, but these 2 are the most widely used. So here you'll say c dot body parser and employee, just like you did in the post API, and you'll handle the error here. So error, not 3 R's, just 2 R's. If error is equal to this, then error is not equal to nil. Then you'll return c dot status 400 dot send string err dot error. Now we're going to start building up the query. Okay. So because why do we want to build up the query? Because the ID that we've just received in this API, right, from the request, for that ID we need to find the exact record in the database, and then with this new data that we've received to update, we want to update or replace that data with this new data. Make sense? So first we need to find the data for that ID. How do you do that? You create a query. You say bson.d, and you'll say key is underscore ID, comma, value is employee ID that you just defined out here. Okay. Then you'll say bson.d, and now what you want to do is you want to build the update query. How do you build the update query? You want to have, so when you do an update query, right, you have to have $set, as in set this new data for instead of the old data. So in case you already are familiar with MongoDB, it will be very easy for you to understand. If you're new to MongoDB, just remember that with $set is the operator that you have to use inside MongoDB to set this data for the data that you are replacing. So this is how it's going to look like. It's going to be bson.d. Inside that you'll have a key, and the key will be $set, like I just mentioned, comma. There'll be a value for that, and the value is defined like this. It's bson.d. Inside that you have three things. You have three things inside here. Three things because there are three fields to it. One is the name, comma, value employee dot name, and here you'll have key age, comma, value and employee dot age. Then you have key salary, comma, value employee dot salary. Make sense? Here you'll just put a comma here, and then here also you'll put a comma. So now that we've built this query, you wanna capture this in this variable called update. And now you can see all the squiggly lines went away quickly. And you want to write the update function. So the update function that you get with MongoDB is called find one and update. So you'll say find one and update. You pass c.context in it. You pass the query. And when I say query, I mean this query that I just created with the ID. So you find that variable with the ID. And the update basically is the query where you set the new data for that particular ID, right? So you pass query and you pass update, both of these things. You say .err here. And where do you want to run this? You want to run this very similar to what you've done before, right? You want to run this query in the Mongo instance like this, the instance that you have, right? The Mongo instance, which is mg dot database dot collection, just like you did here with your app.get, right? So the same thing you want to write here. You want to say mg dot db dot collection, and inside that collection you'll say employees, right? And error is equal to all of this. Now you'll handle the error. So guys, I just need some energy drink because I'm getting a little like it's a long video. If you don't mind. All right. So if error is not equal to nil, that means that the filter did not match any documents. So you want to say if error is equal to mongo dot error no documents, right? So So if there's an error, and an error is that MongoDB does not have those documents, then you're going to return c dot send status 400. So 400 status, you mean it's for not found. That means whatever ID that you're trying to find and replace the data for, it does not even exist. So there's something wrong. So that's what you do. Otherwise, if there's a regular normal error, then you just want to return 500. All right. And you want to set the employee ID. So you'll say employee dot ID is equal to ID param. And if everything has gone well, you want to send 200, saying everything is okay. You want to send the employee. So you'll say return c dot status 200 dot JSON and employee. Cool. Now the only function that we're left with is the app.delete function. But you may have realized that till now we have not actually started our server, right? We've not written anything to start our server. So to start our server, we'll just have to do just this app.listen on port 3000. And if there's an error, you want to enclose this whole thing and you want to say log.fiddle. So if the server does not start due to some issue like the port is already taken or there's some other issue, we'll just basically be able to log out that fiddle error. Now you want to start building the delete function. The process is very similar. You want to, as soon as somebody hits this route or API, you want to call this function which accepts C. You'll have fiber.ctx and it returns an error. Inside that you'll have now you obviously want access to the ID, right, which is inside params. So you'll say c dot params. Inside that you have your ID and you want to enclose this whole thing into object ID from hex and let's say printf dot. So instead of doing those two steps that we did earlier, like primitive.object ID from hex ID param and then doing this, we have done both of those things in just one step. So if I did this earlier in one step, you would have been confused. So this is why I showed you how to do it in 2 steps and now how you can do it in actually just 1 step. And you get access to employee ID directly. This means you don't have to do all this part with ID param and then employee ID, right? You directly got access to the employee ID. Anyhow, now you can handle this error. So you'll say if error is not equal to nil, you'll return c dot send status 400. That means that probably the ID that you got here is not valid. So that's why you'll say it's not found 400. Now, what you want to do is you want to find the record with that ID and you want to delete that record. Okay, how do you do that? You'll first have to always, like you've been doing till now, you have to build a query because MongoDB understands queries. And the queries are in JSON format. And this is what the query looks like. It has a key and this key, we're going to pass the ID, has a value. And the value is employee ID. Okay, so it has a key and a value. And I've put a double quote here by mistake, so that's why everything looks off. And now it's kind of fixed. And now I want to do the same thing. I want to call the delete one function. But wait, how do I get access to the delete function? I'll have to access the Mongo instance. I'll have to access the database. I'll have to access my collection. The collection is called employees. And inside delete one, you're going to pass context, comma, and percent query. Just make sure the spelling of context is correct. And whatever you get back from this, right, from running this query, whatever you get back, you store in result, or you get back an error. And you can handle the error now. If error is not equal to nil, then you return status internal server error. So let's say return c.send status 500, and if the result is dot deleted, count is less than 1. So that means if it didn't get deleted, then you want to return c.send status 404 not found. Yeah, so you're gonna say that it's basically not found. Okay, if nothing got deleted, if the deleted count is less than 1, so obviously that means there was no record like that. I think earlier by mistake I said, did I say somewhere that 400 is for not found? Sorry, my bad. It's actually 404 that's not found. I got confused. 400 is your other type of server error. All right. And here now, if the record gets deleted, so you want to say c.status 200.json record deleted. Okay. And that's your entire delete function. So in about 168, 169 lines, you are able to write the entire program. Things look good to me, and now I think we should start testing it out and start seeing if everything works all right. So what you want to do now is you want to head over to your terminal. Not this one, sorry. This one. And you want to say go build main.go. Now what happens is, you see this main.exe file, right? So, and since I'm using Windows, it creates a .exe file for me, which is an executable file, and that's what build does. It creates a builds a exe file for you. And what you want to do is you want to now run this program. So you say go run main.go. Let's see if it works. Okay, so we get some issue here. So let's try and fixing it. So we've received this error, right? And what do you make of this? It says there's something to do with Mongo driver, MongoDB client, right? So it's quite apparent that something has gone wrong with Mongo. And if I go to my code and I see that the drivers look fine to me, and I know the code that I've written is quite all right. And the only mistake that I see right now is with Mongo, obviously, is that I've not put a slash here at the end. And maybe when it's trying to add this with the database name, the whole thing is kind of failing. Maybe, right? That's my hypothesis. And I save it and I run it again. And I'll have to build it, obviously, first. And then I'll run it again. If you don't build it, sometimes it runs the old executable file, so just build it. And now I can see that it's running the program. So that was the mistake, right? So with Golang, you don't have to be a genius to solve errors. So that's why I am very comfortable writing a lot of code and not testing it again and again. With other languages, right, you have seen other like instructors, they have to keep showing you how, just build a small part of the code and then they test and check it out if it's working or not. With Golang, you don't have to do it. Just write everything all at once and then easily you can debug it. You don't have to be a genius because it'll tell you the exact issue where the issue is, right? Anyhow, so it says fiber is working on port 3000. There are 5 handlers, processes is 1, PID is 21308. All right, so now you head over to your Postman and you come here. I've created a set of collections, so get all employees, which is basically localhost 3000/employee. And I get all the employees that I have. And right now it's saying that I have 0 employees, right? It's an empty array. Obviously, we have no employees. That means I'll start creating employees. So firstly, I'll create an employee called Akhil. That's created. So it's created it for me. And I'll create another employee called Rupert. Now I see that there's another issue. There's a duplicate key error issue. Okay, so this means there's something wrong happening with our ID. And I kind of suspected that when I was creating Akhil, it didn't show me an ID. That means there was something wrong there as well. So now let me try and fix this ID issue. Back in our code, in the post function, everything looks all right to me. That means there could be some issue here. Yes, now I see the issue. There's just one small space between ID and Amit, empty. So let's remove that. And now I think it'll work because this format that I had gone for, it probably MongoDB did not understand it. So let's cancel our process, build main.go and run main.go. And now I'll allow access on my firewall. And so let's try adding some employees. Let's try adding Robert. Cool, you get an ID here now. And you add Alex. Right, so you're getting these IDs here. You get all employees and you'll see so many employees, right? Now what you're gonna do is you wanna edit an employee. So let's edit Rupert. So I'll take this ID, go to edit employee. Just see that it's localhost 3000/employee/ the ID of the employee. So the ID of the employee is what I wanna replace. And I can send in data here that I want. I'll change his name to Peter. And when I do that, Rupert's name has been changed to Peter. So if I get all employees, that second Rupert has become Peter, but this first and third Rupert are always still there, but the second Rupert has now become Peter. Okay. You want to delete an employee now, so you just copy and paste his ID again for delete employee. When you paste it here, send record deleted. Now when you get all employees, you'll see that Peter is not there. So the first Rupert is there, second Rupert is there, and Peter can't be found. So you can see that, right, the issue that we were having earlier was that ID was not being generated for the first record. And if I was trying to add more records, it was saying that that same ID already exists. So it's an error for MongoDB. But now the IDs are being generated because I removed that small space. So all the APIs are working perfectly. Here's your little human resource management system. You can create employees, delete and update employees. You've learned how to work with Go Fiber, which is a very nice library. You've learned how to connect a program which uses Go Fiber with MongoDB. I hope this video was really informative and you learned a lot. So there are many more videos for beginners on my channel. To check them out, you'll have to just go to the videos tab and find them. Just scroll through them basically. And I have like complete playlists for intermediate and advanced developers. I have complete playlists. So in case you're feeling more comfortable with Golang now, you can check out my little intermediate and advanced series as well. Thank you for watching. Do subscribe to this channel so that you can keep seeing this awesome kind of content. And if you have any suggestions for any more type of projects, do put them in the comments below. And thank you for watching. Do share this with your friends if they're also learning Golang, because this is probably possibly the best content that you can find on the internet to learn Golang, right? Not kidding. It is the best content that you can find. So try searching on YouTube. Anyhow, so thank you for watching and I'll see you in the next video.